Welcome back. In this video, you're going to be learning a couple of things. You're going to be learning about motion maps, which is basically how we draw motion. You're going to be learning about position, velocity, acceleration, vectors, and scalars. Let's start off by talking about motion maps. So one of the most basic ways to show an object's motion is by drawing a picture of it every second. If you look at this first diagram, you can see a picture of a car every second that it moves. So the cars are pretty close together. If you compare that to the lower diagram down here, the cars are a little bit further apart, showing that the car is going a lot faster. In addition to showing how fast the car is going, you can also show the direction. If you look at the third image on this worksheet, you can see that the car is going left. It's quite easy to see because the image is going left. This is our most basic way of showing motion of an object. The next way of showing the motion of an object is by replacing that car with a dot. So you put the dot there, and then you draw an arrow. The arrow shows the direction of the movement in addition to showing the size of the movement, so how fast the object is going in this case. These arrows are all the same size, showing that the car is not speeding up or slowing down. If you compare it to the next set of arrows, they're further apart, they're a little bit bigger, meaning the car is going faster, and they're the same direction. If you go even further, going left shows that they're going the left direction. We can even get more complicated with these arrows. In this image, the car speeds up to the right, or actually goes the same speed to the right, stops, so you have a dot with no arrow, and then moves left afterwards at the same speed or a little bit slower. In this image, we can compare two different types of cars. Car A starts a little bit over from the origin being the X on this bottom line, and moves at a constant speed to the right. Car B starts at the origin, moves a little bit faster, and passes car A, moving also to the right. Looking at those same two cars, we have one additional way to represent their motion, which is graphing. Here we have a graph of position versus time. Car A and car B are both graphed on. B goes a little bit faster, car A goes a little bit slower. B also starts at the origin, you can see here, and A starts a little bit past the origin. At this point, we can see both the cars pass each other. We know this because the lines intersect. Car A goes a little bit slower, and we can tell that because the line is a little bit less steep. Car B goes a little bit faster, and we can tell that because the line is steeper, or more steep. Using this graphing method, we can also get some useful equations for ourselves. We get the equation of the line, or the line of best fit, as we've been using in our labs. We can get a useful equation. Equation of a line is y equals mx plus b. In this case, we've changed the letters because they represent something to us now. So the y becomes x because it's the position, it's the y-axis. The m becomes va, the speed of car A, or line A. The x becomes t because the x-axis is now t. And the b becomes xi, starting position for line A. For car B, there is no xi, there's no starting position, it starts at the origin. And VA becomes VB because now it's the speed of car B. The letters next to those letters, or the subscript, represent what that letter is. So VA and VB we can tell apart because one is VA, one is VB. Speed of car A, speed of car B. And the I next to the X tells us that is the initial, the starting. You remember the beginning of this video, I told you would be learning various things. One of them was vectors and scalars. You actually have just learned about vectors. Vectors are the arrows that we were drawing before. It's anything that has a direction and a size. So the arrows show a size by the length of the arrow, and a direction by what direction the arrow is pointing. So this arrow has a different length than this one, meaning it's a different vector, and both of them have a different direction than this one, meaning it's a different vector. Scalars do not have a direction. They only have a size. Can you think of an example of a scalar and a vector? I hope so, because you should now do that and bring it to class.